Hi everyone, welcome back to Alibis and Corroborators. Today we're going to talk about research methods in psychology and law, and this is going to be kind of an overview of the research process so that we're able to dive into the specific example of alibis and corroborators moving forward. But this is the basic kind of overview of how social scientists do research. So the research process has kind of two major components to it. There's critical thinking and empirical hypothesis testing. So critical thinking might be things like challenging assumptions or systematic observations, but regardless, there's still a reliance on empirical evidence within the research process in order for it to truly be research. And so challenging assumptions could be something like, saying, I assume that X is true, let's figure out or test if X is true. Systematic observations could be like, well, I've noticed that X seems to happen a lot, maybe that is true. With empirical hypothesis testing, there's two kinds of categories of empirical hypothesis testing, and this is the actual research process specifically, and there's theory-driven hypotheses and observation-driven hypotheses, and we'll give you examples of these here on the next slide. An example of a theory-driven hypothesis would be something like you have this idea that kind of logically makes sense and has some kind of evidence to support it. So you might say something like, I believe that studying makes you smarter because you review material outside of class, right? There's a logic to that, right? You're going to learn the material better if you study it over and over and over again. Now, we might hear that right now and say, well, no kidding, that's obvious. Well, it's obvious because we've been told it our whole lives, because there's been several studies that have shown that that's true. There's another belief, right, in society we'll hear, like, less guns will make society safer, right? And so that's a theory that having fewer guns in society will make it safer. Now, whether that is true or not is actually something that's highly debated, but that's a theory-driven hypothesis, right? Examples of observation-driven hypotheses are where you notice something, right? You notice that students who sit in the front of the classroom seem to get higher grades, and therefore you might then say, or test that and say, I want to see if that's true across the board. Is it just that proximity in the classroom is leading to higher grades? Or you might notice that certain neighborhoods seem to have higher crime rates, so perhaps there's something structurally about that neighborhood, and so we start to test that neighborhood against another neighborhood to try and figure out what is causing these higher crime rates. Both of these are legitimate hypotheses, by the way, and it's okay to have a theory-driven hypothesis versus an observation-driven hypothesis. You just need to have something on which to base your hypotheses for it to truly be a scientific hypothesis. So you guys have probably all seen this over the course of your academic careers, but the research process is really based on the scientific method. And a method is just kind of any sort of system in place that you are going to follow. And the scientific method is just a set of research principles and methods that help reach valid conclusions. And so if we do something systematically in this certain method, we can then say it's science, right? Science does not necessarily have to involve test tubes. Science doesn't have to involve a Bunsen burner, right? The science is a method or a systematic way of going about testing a hypothesis. A theory is an integrated set of principles that explain or predict observed events. There's a whole classes you can take on theories in social sciences or natural sciences, and theories are one of those kind of hotly debated constructs within the sciences, because those principles, how many of those principles need to be true in order for the theory to be supported or falsified, and there's a lot of debate about that. But a theory in general is an integrated set of principles to explain events. A hypothesis is a testable proposition that describes a relationship that may exist between events. What's very important about a hypothesis is that it's a testable proposition. It has to be testable, otherwise it's not a hypothesis. I could hypothesize that God exists, but that's not really a hypothesis because there's no way for me to support or falsify God in a scientific manner. There are ways to do that in faith, but faith is a separate method from science. Operational definitions, this is an important and often overlooked step in the research process, but it's very important to have operational definitions, which is a concrete definition of a research variable in terms of the procedures needed to control and measure that variable. And so we could also talk about a conceptual definition here, but it's really, really, really important that we define exactly what we mean when we say something. You'll hear this debate or this issue brought up quite a bit, especially as it relates to gun control. People will say, well, AR-15s are military-like rifles because they shoot these dangerous rounds. And then the kind of pro-gun folks will say, well, look, here's my hunting rifle with the exact same bullet. Is this gun an assault rifle? And most people would say, well, no, that's a hunting rifle. Okay, well, if the definition of an assault rifle is the bullet, then any gun that fires that bullet should be defined as an assault rifle, but you're saying this hunting rifle doesn't count. And so you'll see this debate because there isn't really a strong concrete definition of what an assault rifle is that causes quite a bit of that debate to continue to flourish. And I'm obviously not taking a stance on that debate one way or the other. I'm just saying that's one of the issues within that debate is the lack of this operational definition. So within operational definitions, right, the definition should not change haphazardly to fit a belief, right? So, for example, we have in our society right now abortion, which, depending on the state you live in and stuff, is allowed or not, really. And we talk about what life means in terms of abortion differently than we talk about what life is, for example, in the Unborn Victims of Violence Act, which suggests that if you are a woman who gets battered and you lose your baby in that battery, the offender could get charged with a homicide of that baby. And so we have a different definition of life depending on the context, which means we have a very weak operational definition for that. Most disputes in life revolve around this lack of or unclear definition. And the issues, and this is an issue, by the way, in a variety of different relationships, right? You or your parents' definition of what a clean room is, right? If there's not an operational definition of no, your clothes have to be folded and put in the drawer, not balled up and thrown in your drawer, you're going to have an issue. Your romantic partner's definition of cheating or what quality time means to you. Like, what do you mean we don't spend enough quality time together? We lay in bed 8 hours together every night together. Well, you're sleeping though, right? Is that really quality time? Your best friend's definition of loyalty, your boss's definition of how long a lunch break should or shouldn't be, right? All of these things cause problems in relationships because of unclear definitions. And unclear and ill-defined definitions will always cause bad research and, as a side note, bad relationships because you're not actually explicitly stating what it is that you're doing. So we need to have clear definitions so that, especially in research, so we know what it is that's being measured and how it's being measured to make sure that it's being done properly. So the research process is cyclical, right? We have a theory, and just for sake of argument here, we're starting with a theory that leads us to hypotheses, that leads us to empirical research, and we get the results of that research, and we have to then revise some things to make the theory work better. So let's say I had a theory that sitting in the front of the classroom means you're going to get a higher grade than sitting in the back of the classroom. So that's the theory, is that the people in the front of the classroom are smarter. My hypothesis is because they can see the board better, they are getting higher grades, and I test this. And I find that 3 out of 4 people in the front of the classroom get A's, but 1 person gets a C. So then I have to figure out, okay, well, maybe it's not sitting in the front of the classroom by itself, so I've got to revise the theory. And so I survey those 4 people in the front of the classroom, and I figure out the 3 that got A's also read. So now my theory is if you sit in the front of the classroom and read your textbook, you'll get a better grade, right? And so then I test that theory and I slowly figure out over time what it is about the sitting in the front row of the class that actually gives you higher grades versus sitting in the back row of the class. And really, I don't know that there's any relationship between where you sit in the class and your grade, especially because you just kind of wander in on the first day and find whatever open seats there by the door, right? And so, but that's just kind of a silly example. So goals of science, there's a bunch of different goals of science, right? And depending on what your research question is, should determine your methods and also determine what kind of science you're going to be doing. So there's descriptive science, right, where you're just trying to describe an event or a phenomenon, right? If I want to know how safe St. Augustine is, I might want to know what's the murder rate per 100,000 people in St. Augustine compared to Jacksonville and Daytona, right? And St. Augustine is very, very safe. And so all I need to do is a descriptive study to figure that out, right? I might want some sort of predictive measure, right? So anticipating an outcome based on theory or observation, right? Childhood abuse leading to violent offending, right? I can predict that if you are a victim of childhood abuse, we need to give you a whole lot more resources than maybe people who aren't victims of childhood abuse to make sure you don't continue to offend. And then there's also understanding, which is instead of trying to predict an outcome, let's try and really dive in and understand why certain outcomes are happening. So for example, racial disparities in sentencing length. Why did that happen? How did we end up with these vast differences? Is it because inherently America is racist? Is it because we structured laws based around certain ideas, around race or possibly around poverty, and then that has led to these disparities? Let's really try and dig in and understand why something happened. So within methods of hypothesis testing, we see there's several different types of studies. There's observational studies, correlational, and experimental studies, right? Observational studies might be things like describing phenomenon in question, right? I'm just going to observe something and describe what I see. And all of these we'll go into more detail on. And so if I go through these quickly, that's why. Correlational studies predict a relationship between X and Y, but don't necessarily say that it's causal. They just say they're somehow related to each other, right? One of the examples of this that every, high school stats class uses is ice cream sales and drowning have a very high relationship that are very highly correlated with each other. But that's in large part because most people swim in warmer months and most people eat ice cream in warmer months, right? So they're correlated with each other, but it's not, ice cream sales is not causing drowning to happen, right? And then there's experimental studies that try and determine if X does in fact cause Y. So correlational studies, we hear this all the time, correlation doesn't equal causation. In experimental studies, we are actually doing or trying to find causation. All else being held the same, when we introduce X, suddenly we get a change in Y. It's safe to say X is causing Y, at least to some extent. So observational studies are systematic examinations of behavior in certain people or in certain conditions, right? This could be participant observation, this could be archival analysis, but it might be something where I want to see, I have a theory that men like bourbon more and women like vodka more, so I'm going to go to the bar and I'm just going to tally up what people order in terms of liquor to see if my theory is true that men in fact like bourbon more and women like vodka. That's just participant observation, right? There are some shortcomings to this, though. Some behaviors are more frequent than others, right? Let's say I go to a bar that specializes in bourbon, right? Or if I go to a bar in the Southeast, right, is very heavy bourbon drinkers, right? I might just happen to see some behaviors more just generally, and it might not be very generalizable. Results could also be biased by the observer, right? What if someone orders a gin cocktail? Gin is vodka soaked in juniper berries. Does that count as vodka? And so I check it for the vodka category, right? I might accidentally bias it as the observer. This is also limited to specific groups, settings, and behaviors. There's only so many things you can observe ethically, legally, and also practically, right? It's also very, very, very messy. For field research, you need about 4 hours of non-note taking for every 1 hour you spend in the field because there's just so much that happens in a systematic observation that becomes very, very difficult. Correlational studies are just systematic examinations of variables to see the extent to which these variables are related to each other, right? These vary in direction. They can be positive or negative, as you can see on the picture here, and vary in strength from 0 to 1. So, for example, you can see here this positive 1 has a perfectly straight line. So as x goes up by a unit, y is also going up by a unit. A negative 1 is as x goes up by a unit, y is going down by a unit. And that's a perfect negative relationship in 1. And you can see here the varying differences of strength and direction of correlations throughout on this slide. And again, this just shows a relationship between the two variables. How strongly are they related to each other, and in what direction are they related to each other? So as I already kind of talked about, as temperature rises, ice cream sales increase. As temperature decreases, ice cream sales decrease, right? That's a positive relationship or a negative relationship. No relationship is temperature doesn't really vary as a function of the days of the week. Wednesdays are not just warmer days than Thursdays, right? There's no relationship between day of the week and temperature. A negative relationship could be as temperatures rise, people wear less clothing, and as temperature decreases, people wear more clothing, right? As one goes up, the other goes down, right? Or as one goes down, the other goes up. There can, though, be possible reasons why a correlation exists. So it could be that X and Y are related to each other, or it could be that there's this other variable Z that pops in that explains this relationship better. So, right, as we talked about ice cream sales and drowning, right, if ice cream sales and drowning are related to each other, it could be as a function of temperature that's really masking this relationship. So some examples of correlation not equaling causation are things like housework cuts breast cancer risk. The more you clean your house, the less likely you are to get breast cancer. Well, those things are probably not related. Intelligent children are more likely to become vegetarians. It could be that people are like, whoa, we don't want animals to suffer and we're more enlightened and therefore we're vegetarians. There's probably something else going on there. And here's several other examples. Fear of hell making us richer, wearing a helmet puts cyclists at risk, sex cuts public speaking stress, right? All of these things are just kind of silly examples where correlation doesn't necessarily equal causation. It could be that wearing a helmet actually doesn't put cyclists at risk, but it makes cyclists feel safer, so they're more willing to do risky things, and then they end up getting hurt, right? And so the helmet is not actually a danger. Finally, experimental studies are systematic observations of whether a particular factor causes a particular effect by having a researcher manipulate one variable at a time and randomly assigning participants to conditions. So there's two variables here, the independent variable and the dependent variable. The independent variable is the variable that the researcher manipulates in the experiment, right? This is the cause. The dependent variable is dependent on the independent variable, or a variable that the researcher measures in the experiment, or the effect, right? And so an independent variable could be if I wanted to see if men or women participated in extracurricular activities on campus more, right? The independent variable would be gender, even though I'm not necessarily manipulating gender in the strictest sense, right? What we're trying to see is, does gender predict, is gender the cause of the effect, which is participation in extracurricular activities, right? And so the researcher is measuring the dependent variable and controlling the independent variable. In experimental studies, the kind of classical experimental design has a control and a comparison group. The experimental group is any condition of an experiment in which the participants are exposed to that independent variable, and a control group is a condition of an experiment in which the participants get what is normal. So, for example, if I wanted to measure if college students who ate eggs for breakfast did better on an exam, right? I would take two groups of college students. One of them I would give eggs to, one of them I would give Pop-Tarts to or something, right? And I would see if the grades were different between the egg group or the experiment group and the Pop-Tart group or the control group. Random assignment, though, is important. I should take all of the students in my class and randomly divide them up in the egg group or the Pop-Tart group. I shouldn't just have all the smart people in the egg group, because then, of course, the grades are going to be higher. I also shouldn't separate them based on any sort of real grouping. I shouldn't say the first half of the alphabet, because that's not random then, right? It could be that in that class I have, the first half of the alphabet also just naturally has better students in them, right? And so random assignment's important. There are times, though, that you can't do random assignment. So, for example, if I wanted to compare victims of child abuse to non-victims of child abuse, I can't randomly assign parents to abuse their children, right? So the randomization has already kind of happened. And so that makes it quasi-experimental. It's pretty close to experimental, but it's not quite. Regardless, though, the reason random assignment is so important is because it helps control for those confounding variables, like all of the smart students being in one group, right? And so random assignment becomes important to help kind of weed out a lot of those possible issues. A bonus here is that causal inference is possible. It's very, very high in internal validity. Because the experiment is so controlled, and you only manipulated one variable or two variables, you can make causal statements. If I use random assignment, right, and I give one group eggs and one group Pop-Tarts, and the egg group on average gets an A and the Pop-Tart group on average gets a C, I can say that eggs for breakfast before an exam will give you a higher grade on average than Pop-Tarts will. However, it's very low in generalizability, right? Even though it's high in internal validity, it's low in external validity. Because we controlled the environment so much, we can't make generalizations without replications across people, situations, and stimuli, right? Because I'm a criminology professor, it could be that eggs help you do better just on my personal criminology exams compared to Pop-Tarts. It could be that Pop-Tarts would help you do better on a biology exam, right? And so we have very low generalizability in this because we only tested it with one kind of exam, with one professor, with one kind of food, not across the board, right? This is a huge issue for attorneys and judges. Kind of like we talked about in the first lecture, attorneys and judges want there to be more generalizability and want there to be more external validity than what social science can give them currently. So there are some issues in psychology and law research, right? There's experimenter effects, right? So for example, race effects in jury decision-making studies. If the experimenter is trying to kind of artificially manipulate certain things and say, okay, we want to see, the effect of a black defendant versus a white defendant, but all of the jurors are only white college students. Well, that's kind of a problem, right? Because there's this kind of same race bias that people naturally have that might be affecting the results of the study. There's also replicating social settings. Interactions between police officers and an eyewitness during an investigation are really, really hard to manipulate in a lab. It's very different when a police officer with a badge and a gun is asking you something and you feel like you're worried about getting in trouble versus you show up to a research lab where we have to tell you at any point you can leave the room with no worries at all. And I'm not a police officer with a badge and a gun. Also deception, right? How do you replicate a false confession? How can you replicate the stress of being interrogated in a lab when someone knows, number one, they didn't commit a crime, two, knows that a researcher can't arrest them and put them in prison for the rest of their lives, right? And also ethically, if we could somehow simulate that, should we be doing that to participants? Is that ethical or not? Or are there moral issues with trying to replicate a false confession? So generally, how are research findings shared? They're shared in literature reviews and experimental articles. And your textbook for this semester is kind of a hodgepodge of all of this kind of together. So literature reviews are reviewing a topic area to determine commonalities in similar studies, right? So here's what the literature says about this topic. Here's how we organize this review so you can kind of understand what's going on. Every now and then there are special literature reviews that have statistical analyses to them called meta-analyses. This is a statistical literature review where someone brings together a large number of studies that have examined similar phenomenon and combines them all to see what's generally found. A lit review kind of lists, here's what all we've done. A meta-analysis is actually an analysis saying, in general, here's the effect we see. There's also experimental articles. This is a discussion of one study or a series of studies about the same topic that attempt to answer basically one research question. So an experimental article will kind of say things like, I wanted to know if, in the kind of weird example I used, if eggs or Pop-Tarts are better, here's how I did it, here's the theory behind why I think it matters, here's what I found, and now we've answered that very specific question. And so it's important to kind of understand what it is you're reading also when you are reading psycholegal research. So this is a basic overview of how social scientists kind of do the research process broadly. We're going to go into a lot more detail about some of these things as the semester goes on, but this is kind of an overview. So when I say here's a correlational study or an observational study or an experimental study, you kind of have an idea of what it is you're looking at. As always, if you have any questions, please just drop a comment down below or feel free to email me anytime. I'll talk to you soon.